Alrighty, well, welcome to Unit 6, which is Inference for Proportions. And remember, we use proportions when we're dealing with categorical data. So in this unit, what we're looking at is we are trying to estimate or find significant evidence about some type of population parameter. Now, in the past, we assumed that we knew the true value of the parameter, and then we asked questions about the distribution of the statistic, which we used to estimate the parameter, right? This was our sampling distributions. Well, now we no longer pretend that we know the truth. Instead, we're starting to look at more realistic situations where we know only the value of the one statistic, and then we try to estimate the parameter based on that value. Well, in order to estimate an unknown parameter, we're going to use a statistic that provides a reasonable guess. And we're going to call this chosen statistic a point estimate for the parameter. So that could be p hat estimating p, x bar estimating mu, or s estimating the sigma. So in order to use this point estimate, we're going to use what's called a confidence interval. And this uses sample data to create this estimate. And also, we'll deal with some things about variation and preciseness about the estimate. So there are two things we have to consider when looking at a confidence interval. The first one is the interval will be given to us in the form AB. And the second one is a level of confidence. You know, we are 90% confident, 95% confident. We are going to be every level of confident except 100% confident because you know that we never know the truth in statistics. So this is the idea of a confidence interval here. You have your endpoints, and then here in the middle of your interval, your point estimate is that sample statistic. So based on that statistic, how much variation do we think would contain where the parameter is? So is the true P closer to A? Is it closer to B? Is it closer to P hat? We don't know. Again, we're just estimating or guessing. Now, when I go to my AP Stats formula sheet, at the bottom of the first page, you'll see sampling distributions and inferential statistics. We are going to start looking now at these boxes. And we're going to look here at a confidence interval. So we typically say point estimate plus or minus the margin of error. So this distance here between P hat and B or P hat and A is the margin of error. That's how much variation there is. That's how much our guess could be off by. But somewhere in that interval, we think the truth lies. So we will use the point estimate plus or minus the margin of error. Now, if we look at our formula sheet, they have a more specific formula, which is a statistic, which could be P hat or X bar, the critical value, which we'll talk about a little bit more later, and then the standard error of the statistic. So now when we go back, you'll see standard error here. I'm using proportion, so I'm only going to be looking at these two boxes for this unit. So I have for one proportion, here's how I'd calculate the standard error. Or for two proportions, here are some ways to calculate the standard error. Now note that the means will be the same, but the standard deviation will change. Here, this is a standard deviation if I know the parameter, but when I'm making it based off of the sample, it's going to be called the standard error. So there's a distinction there. Standard deviation from the sampling distribution and the standard error of the sample. Okay. So enough hoopla. What is a confidence interval? Well, let's suppose that 40% of the population has some unknown characteristic. Well, I'm going to take large samples of size 100 here, and I'm going to see in that 100 what would be the sample proportion. So let's say I take a sample. Well, here's the truth. The population parameter is about 0.4. In my sample that I took of 100 people, I had about 39 successes for this characteristic and 61 failures. And remember, a success doesn't mean a good thing, and a failure doesn't mean a bad thing. A success just means it happened, and a failure means it did not happen. So that was my first sample. Okay, well, let me take 5 more samples. So if I take 5 more samples, notice that, okay, in this confidence interval, its own sample, let's see, we're between 26 and 45%, and we did capture, 40% is definitely in there. In this confidence interval, we're between 21% and 40%. Again, we barely capture it, but we captured it. In this sample, 32% to 51%. Here, 31 to 50, but in this sample, we were above the parameter. We actually did not capture it. So we're not always guaranteed to capture the truth. Again, we're estimating. So you can see here that my sample proportions are starting to vary. Each time I take a sample, due to sampling variability, you know that we're going to get some different results. So we will use these two formulas. I'll give you the interval from A to B, And I want you to find the middle of the interval. So we'll use this formula because we're looking for the middle, the midpoint really. And then if I ask you to find the margin of error, you will use this formula. Now, this is only used when the confidence interval is provided. We're going to learn in this course how to construct the interval by hand. But as an introduction, sometimes they give you the interval, and we're going to do some things with that. So notice in my example here, in the simulator that I was using, if I were to take, let's say, let me take 100 samples. Actually, that might be too many. Let me take 25. All right, so we notice that we're doing pretty good. Most of the intervals are capturing the truth, but every now and again, another interval will miss it. So let me do 50 instead. Okay, so now we can see 48 of my intervals captured the truth, but 2 did not. Okay, let me try 100. Okay, now we're starting to see, as I'm taking more and more intervals, while I'm getting more successes of intervals capturing the truth, I'm also getting more intervals that are not capturing the truth. So let's say I did 1,000. Now you're going to see some reds that are completely far off, and it's telling me here that the intervals that contain the truth, these numbers are cut off, are about 95% of those intervals, which means about 5% of them, these red intervals here, are not capturing the truth. And the reason that is because we're not always guaranteed here. Looking at these intervals here, we can see that they don't all capture it. For example, this one misses the parameter, this one misses the parameter, and this one misses the parameter. We have 20 different random samples here, so only about 17 out of 20 of these capture the truth. And because of that, not all of the confidence intervals will capture the truth. And that's because our process of making these intervals is based off of one random sample that we selected. Now, you and I both know that we should use the law of large numbers and that we should constantly be looking at the long run average. Now, why is it that they might not all capture the truth if I'm taking random samples? Remember, when we randomize, we don't eliminate bias, we just reduce the bias. Now, why is each sample completely different than the other one? Well, we all know our favorite vocab word in this class is the sampling variability. Right? Some samples might be the same, some samples will be completely different, some samples will capture the truth, and other samples might not ever capture the truth. But due to this sampling variability, we're going to get this we're going to get some intervals with the truth, some intervals without the truth, and of course, we're trying to estimate the truth. So that is the difference there. The confidence interval is what we're doing. So each of these little spider-looking things is the confidence interval. That is our best estimate. The confidence level is that long-run average. How many of our intervals in the long run do we expect to capture the truth? So key distinction there. And we're going to use these sentence stems here. So we are C% confident. That'll be defined in the problem for us. And it should say we are C% confident, not confidence, I'm human. We are blank percent confident that the interval from blank to blank captures the true population parameter. In repeated sampling of size blank, this percent of all constructed intervals from the population will capture the true parameter in context. So let us take a look here at an example. And in this example, we have a random sample of 100 teenagers in Florida. And this is a 95% confidence interval for those proportion of high schoolers who favor chocolate ice cream. And we believe that it's between 32 and 42%. So the first thing that I notice is that it says the proportion of high schoolers. I can't take the average favorite ice cream flavor, but I can see how many people tend to favor that flavor. So this is going to be categorical data. This is a proportion as stated. So I'm going to want to construct my p hat here. And the lower bound is called A, the upper bound is called B, and then this 95%, that's our confidence level. We are 95% confident that is happening. So to find the point estimate and the margin of error, I want the middle point. So I will take the average of the two endpoints, and I get that my point estimate is about 37%. Then to find the margin of error, I'll find that distance between p hat and one of the endpoints. And again, I use my formula, and I get it's about 0.05. So notice that the interval can be given to you. It could also be given to you mathematically. So you just have to be able to bounce between the multiple representations. So here my point estimate is 0.37 and my margin of error is 0.05. So what does that look like? Well, if I were to interpret the interval, I'd say that I'm about 95% confident the interval from 32% to 42% captures the true proportion of teenagers from Florida that would prefer chocolate ice cream. So I think that the truth is somewhere between those two values. I don't know the exact value, but I do believe it's somewhere in between those two. Now, that was one random sample that I took of 100 teenagers. What if I kept taking all possible random samples? And thinking back to sampling distributions, when we take all possible, we are getting a better idea of that true parameter. Well, here, in repeated sampling of size n equals 100 teenagers, we would expect about 95% of our constructed intervals to capture the true population proportion that would prefer chocolate ice cream. And that's back to this idea here, where if I kept doing this again and again, and I did it for all possible samples of size 100, I would expect that about 95% of those intervals in the long run are going to capture the truth. All right, now, last thing here. When you have a confidence interval, one big thing is asking to justify or to verify a claim. So is it plausible that 40% of teenagers in Florida favor chocolate ice cream? Why? Well, 40 would happen somewhere like right there, and 40% is most definitely in our confidence interval, and we think the truth is somewhere in there. So yes, it is plausible that 40% of teenagers in Florida would favor chocolate ice cream, since that value is within the confidence interval. So we are about 95% confident it could be a thing. So we've never said yes, we never said you should expect. We just said that it could be there, could not be, who knows. But we're about 95% confident. So we have 5% forgiveness here. All right, well, go ahead and pause the video now, and I want you to take a look at this example here. I'm trying to move my face so that it won't distract you, but oh well, you'll figure it out because you have your notes, you're following along. Go ahead and pause the video, look over this question, take your best guess, and then we'll go over this together shortly. So go ahead and pause now. All right, so hopefully not too difficult, but you should have gotten answer choice B, because notice that it says the proportion of all registered voters. In some of the other answers, you'll see that the sample proportion, well, no, the confidence level is the long run average of the actual parameter. Now, we haven't really learned too much about this margin of error aside from it being a vocab word, but the interpretation is not there. So notice that the confidence level, okay, that was a terrible line. When it asks us about the confidence level, we're looking at the long run process, but the confidence interval is the short run one-time thing that we did. So that's just a little bit of an introduction to confidence intervals. In the next lesson, we're going to actually construct a confidence interval from hand. So stay tuned.